Hi everyone, this will be the video lecture for our introduction to statistics. So what is statistics? So statistics is the study and practice of collecting and analyzing data. So statistics could be facts or summaries about data. What can statistics do? So statistics can be used to describe data or can be establish inferences or correlations, which is a field of statistics, mainly our inferential statistics. So we have two main types of statistics. First, we have our descriptive, which describes the data using a set of measures of central tendency and measures of data spread. The second one is our inferential data, which allows us to make conclusions that extend beyond the data we have. It also allows us to test any idea or hypothesis. However, in inferential statistics, we have a certain degree of uncertainty. Okay, so some terms before we move on to the bulk of the lecture. So when we say constants, these refer to fundamental quantity that do not change in value. Variables refer to quantities that may take any one of a specific set of values. And we have two types of variables. We have quantitative and qualitative. Qualitative, these are non-measurable but can be categorized and weighted. Quantitative, these are measurable either by measuring devices or the use of mathematical formulas. We have a subdivision for quantitative. We have our discrete, which is based on actual values based on counting. And we have our continuous, based on measurements. So we have our population and sample. When we say population, this is a finite or infinite collection of objects, events, or individuals with a specified class or characteristic under consideration. When we say sample, this is a limited collection of objects, events, or individuals selected from the population. So in relative terms, population is always bigger than the sample, and the sample is always a part of the population. Now let's move on to the crash course on how to use Microsoft Excel and how to measure central tendencies. So when we say central tendencies, measures of central tendencies, these are values that may be used to describe a dataset based on the characteristic of the whole dataset. So the first one is our mean or average. So in mean, we take the sum of all the numbers in a dataset and divide by the number of data points. It is useful in relatively normal datasets. When we say normal, it is a distribution of data commonly that has roughly the same amount of data on either side of the middle and has most common values around the middle of the data. So it will look like this one. So this is the bell-shaped curve or the uniform distribution curve. When we say distribution, this shows us how often each value occurs in our dataset or frequency. So this is the bell-shaped curve again. So let us move on to Excel. So I can demonstrate how to use our Microsoft Excel in getting our measures of central tendency. Okay, so we have grades in this Excel file. Let us enlarge it. Okay, so we have the names, the final grade, the converted grade, and later I will be adding a column for a specific measurement. Okay, so first we need to measure how many persons are in the population. So this is actually the grades of selected first year students in their grades in organic chemistry. Okay, So I actually anonymized the names, but I think you can guess which is which. Okay. So first we need to get the amount of samples, or how many people are there in the sample. This is actually the whole population because all first year students were actually gathered. So for population, we just need to count how many names are present. And you can see the number here on the bottom right, count. So we actually have 45 students. So our population is 45. Next, let's have mean. So when we say mean, this is the average of all the grades of the population. Okay? You will not be using pen and paper for this course. Therefore, you are allowed to use Excel. The formula for mean is average. So when typing a formula, place an equal sign before each formula. Average, parenthesis, select the numbers. Close it. And you have your average. So the mean grade of the population is 77.4302. Okay, so that is our first measure of central tendency. Next, we have our next measure of central tendency, which is our median. So the median describes the middle number in which the dataset is ordered from smallest to largest. So to get the median, you have to arrange the data first. Then the middle number is the median. When there is an even number of data, the mean of the two middle data points is used. So not all the time you will get a whole number for median. Median buffers from outliers compared to means. So in means, if you have large outliers, you will tend to have a slanted mean, meaning it skews towards the larger numbers. Okay, so how do we calculate median in Excel? Median has the formula median. And simply select the dataset, and you have your median. Okay, it's that simple. So our mean is 77, while our median is 76. It actually looks like a normal distribution. Next, we have our mode. Our mode is the value that appears most in our dataset. It gives a value that actually appears in our dataset. So it will return a real value, meaning it is not calculated, it is just counted. Useful when you have a relatively large sample, so you have a large number of popular values. This may be used for non-numerical data, especially like color or feelings. Okay, so let's get the mode. To get the mode, I actually converted the grade towards our numerical values. So as you can see, there is a converted grade. This can be termed as binning, since if you get the mode of raw grades, you might not actually get a usable mode. So we bin them. When we say binning, it is actually grouping of our data sets into groups so we can count them better. So let's get the mode of our converted grade. Mode. So you can see in Excel, there are different types of modes. You can use mode single or mode which is cross-compatible. Mode single is appropriate, or is the most appropriate one. Single. Ugh. Okay, yeah. we get the group of data, we're going to use the binned data. Wow, there are actual people who failed. Why did they fail? Ah, yes. Okay, anyway. And our mode is 3. So most of the students got a passing rate of 3. Next, we have our measures of spread. So when we say measures of spread, this describes how well the mean or the median represents the data. So first we have our range. The range takes the largest number in our dataset and subtracts it with the smallest number in our dataset, giving a distance between the two extremes. Okay, so to get the range, you simply have to subtract the maximum value minus the minimum value. Okay, so to get the minimum value, you do not actually have to go through each value. Simply type minimum or min and get the values of the set. And you have your minimum. Next, you have your maximum. You get the dataset. And you have your maximum. So 73.27 is the lowest. And the largest is 91.09. So to get the range, you have to simply subtract the maximum less the minimum. And you get 17.82. That is the range. We can also divide our data into quantiles. So when we say quantiles, these are natural extension of the idea of median in that they are values that divide a set into equal parts. We have two most commonly used quantiles. We have our percentile and our quartile. So percentile is a quantile that divides the distribution into 100 equal parts. You may be familiar with this, in particular if you take any standardized exam or if you're going to medicine. Percentiles are used to judge how far you are away from the mean or how far away you are from the others. So if you're going to apply for UST medicine, you have to get a percentile of 99 plus, meaning you are better than 99, greater than 99% of the test takers in that batch. Quartiles, on the other hand, divide the distribution into 4 equal parts. Okay? And we have our interquartile range, which looks at the spread of the middle 50% of your data. We use interquartile range since in normal distributions, we tend to see the most amount of data or our frequency accumulates in the middle. So let's demonstrate how to use it. So to get the quartile, the formula is quart. Quartile, you can use quartile. Simply get the array or the amount of grades here. And you have to put a comma, then the quartile number. So the first quartile is the 25th percentile. You cannot click and drag, because what will happen is the range actually decreases. Okay, so what you can do as a tip is to put the $sign before each letter and each number. What the $sign does is it fixes that data point. So now you can drag it down and the data will all stay the same range. However, please do check the formula. You're going to get the second quartile, the third quartile, and the fourth interquartile. Okay, and to get the interquartile range, the interquartile range actually is simply third minus first. Subtract the third quartile minus the first quartile, and you have your interquartile range. So this is where 50% of your data should fall. Okay, so we have measures of variability, symmetry, and kurtosis. So for range, we already discussed range. Now let's get the mean deviation. So mean deviation measures the average deviation of values from the arithmetic mean. It gives equal weight to the deviation of every observation. So let's check if we have something like that. We don't have it here. Next, we have our interquartile range. So I will discuss mean deviation on a later date. So interquartile range and quartile deviation. So quartile deviation is interquartile range divided by 2. So our interquartile range is Q3 minus Q1, which we already computed. And for our quartile deviation, we simply need to divide this value by 2. And you have your quartile deviation. Next, we move on to more common values, like our standard deviation and variance. The variance of the population is equal to the sum of the squared deviations about the mean divided by the number of scores. The standard deviation is equal to the square root of the variance, and these are used when the mean is the preferred measure of central tendency. Variance is frequently discussed as an indicator on how much variability there is in a distribution, and standard deviation is used to determine how far the data is from the mean. Okay, so to calculate for our variance, we need to get the variance first. The formula is variance. You will be presented with variance P and variance S. There is actually a slight difference in the formulas used, so I will not explain what the difference is. Instead, I will explain how they are used. So variance P is the variance of the whole population, or variance of the population. You will only use it when your data set is the whole population, while variance S is used if your data set is only a sample of the population. So since our data set is the whole population of the first year students, we're going to use var P and get our data set. So our variance is 12. To get standard deviation, STDev, you're going to select P again for the same reason as earlier. So you're going to get, again, and you have your standard deviation of 3.485. Next, let's proceed. So next we have our standard score, or z-score. So a standard score, or z-score, is a statistical measurement of a score's relationship to the mean in a group of scores. When we say standard score, it means no matter what the actual value is, we can always get it proportional to the mean. Okay, so this is useful when comparing two sets of totally different data. So z-score describes the position of a raw score in terms of its distance from the mean. So when measured in standard deviation units, the z-score is positive if the value lies above the mean, and negative if it lies below the mean. Okay, let's get it. So let's apply a new column. So for here, you need to get formulas, statistical, here. Then you're going to get z-score. Or not z-score. Standard. Oh yes. I think the formula was standardized. It's not so medyo it's slightly counterintuitive. The formula is standardized. So you will get a standard score or the z-score. You will get the standard score. So in the formula, you have x, which is the population, comma. Then you're supposed to select the mean. So we already have the mean in our data. And our standard deviation. Our standard deviation is also in the data. Close it up and enter. And it will it will overflow. So it will actually occupy the space. Okay, below it. Okay, so how do you interpret this? So for example, Haruka, the first one, has a z-score of 0.042. It means that Haruka is actually above the mean. Okay, so Haruka is above the mean. So example, you have a like Ritsuko over here has a z-score of negative 0.44. It means that Ritsuko's score is less than the mean. So let's check. What is our mean? 77. Haruka, 77.43. Haruka's is 77.58. So meaning, it is greater than the mean. It has a positive z-score. Okay. Next, we have our coefficient of variation. So the coefficient of variation is a statistical measure of the dispersion of the data points in a set around the mean. The formula is the standard deviation over the mean. The coefficient of variation represents the ratio of standard deviation to the mean and is a useful statistic for comparing the degree of variation from one data series to another, even if the means are drastically different from one another. So this, instead of a z-score, which describes each data point, the coefficient of variation describes the deviation of the whole data set. So let's get the formula. So it is standard dev over mean. Standard deviation divided by the mean. So our coefficient of variance is 0.286. Finally, last two, we have our skewness. So the skewness refers to the distortion or asymmetry in a symmetrical bell curve or normal distribution in a set of data. So if the curve is shifted to the left or the right, it is said to be skewed. It can be quantified as a representation to which a given distribution varies from a normal distribution. Okay, so you have three possible outcomes for skewness. You could be positively skewed or right-leaning. You could be negatively skewed or left-leaning. Or you can be normal. When we say normal, there is no skew. Okay? So to get the skewness, skew. So we have two types. Let's get skew population. Since our dataset is the whole population. Close it up. Our skewness is 1.82. So we have a positive skew. Our curve is leaning towards the right. So let us check. So how do we check our curve? First, let us get the histogram. So to make a histogram, so I will instruct you how to install the data analysis toolpack later. So you need to go to data analysis from data. Okay. And you have your histogram here. Input range. Let's have here. And let's not bin them. Let's not bin them. So if we do not bin them, it will actually give you a... Let's have the bin range of 1. Instead pala. So let's see what it looks like. And let's have a chart output so we can see. Okay, so let's bin them instead. Let's make a bin right here. Wait. So what is our least grade? 73. So 73, 74, 75, 76, 77, 70. Okay. We don't actually need to go so far. Anyway, let's have 100. 71. So this will serve as our bin range. Histogram. Input range is here. Bin range is this one. Okay. Double check. The input range and the bin range should be different. Select chart output and let's have it here. Okay, so we have a histogram right here. Okay, from this histogram, it looks negatively skewed. It looks negatively skewed because we did not indicate where the mean is. Our mean is actually 77. So right here. Okay. So it is actually a little bit right-leaning, in which there are more data points to the right of the mean instead of to the left of the mean. Okay. So the histogram will actually change from what the binning is made, or how the binning was performed. So I don't think this is the best way to bin these items. Okay. And that will be all for this video. Let us continue on the next video instead. Thank you for listening.